Hi everyone, and welcome to today's public webinar, which will be related to barrier management or SECE management. Today, we're not going to dive very deep into an extensive topic. We're going to scratch a bit on the surface, trying to let you in on what this service area or what this discipline encompasses. And we don't have enough time, of course, to go into details, but I hope to give you some good introduction and also some lessons learned based on our experience working as industrial risk advisors for many years. First, we're going to present who we are, and I can start with myself. My name is Per Ståle Larsen. I'm a principal consultant at ORS Consulting. I graduated in 2009 as an industrial mathematic engineer from NTNU. And I've been worked as an industrial risk management advisor ever since. I have experience with quite a broad range of risk services, and I have worked extensively with barrier management, both during project phase and during operations for a wide range of industries. That's short about me. Over to you, Katarina. Can you present yourself?
Sure. Thank you, Per Ståle. My name is Katarina Linde. I'm a principal consultant with ORS based in Malmö in Sweden. I have a background in fire safety engineering and risk management engineering from Lund University in Sweden. And since 2009, I've been working with risk management engineering, including process safety, technical safety, reliability, and barrier management in various industries, both offshore and onshore. Thank you.
Perfect. Thank you very much, Katarina. Over to you, Terje. Can you present yourself as well?
Yes, thank you, Per Ståle. Yeah, I'm Terje Stølen. I'm a principal consultant at ORS Consulting. I have a background as a structural engineer from the university in Trondheim, and also have studied risk management at the university in Stavanger. I have worked since 2004 with technical safety and barrier management issues.
Very good. Thank you very much, Terje. Okay, I think people are probably eager to get into the details as well. So I'll just start with saying a bit about the agenda. We'll start today. I will give an introduction to what barrier or SECE management is. Then Katarina will say a bit about the interface between barrier SECEs and the CMMS, or the computerized maintenance management system. And then Terje will share some of his experience related to verification of barriers and SECE in operation. And finally, we'll do a Q&A session, so questions and answers. If you have questions as we go along, please post them in the Q&A function in the Teams meeting, and we will get back to them at the end of the session. I could also say that we're going to end at 12:45 sharp, so any questions that we don't have time to answer now, please follow up with either of us directly after the webinar. We'll be happy to answer any questions you have on this topic. Also, a small disclaimer, if we have some, let's say, related to the terminology and definitions here today. So the terms barriers, barrier elements, and SECE, they have slightly different definitions and meanings across various countries and industries. For the remainder of this presentation, the terms barrier and SECE will, for simplicity, be used quite interchangeably. So don't go into the details of the fine definitions of the terms today. What we're talking about are kind of barrier elements of SECE, and I think we can all agree that they share a lot of common features and can be discussed about in under the same umbrella. Yes, I'll say a bit about the context about barrier management, because this concerns major accident hazards, and that's at the core of barrier management. This is why the methodology has been developed, and a major accident hazards has various definitions, but it always, I would say, involves some kind of major severity. So it's a big accident and typically acute incident. We have a major spill, fire explosion, immediately or subsequently multiple serious personal injuries, harm to environment, or loss of major financial assets. So these are the big events. It's the Deepwater Horizon, it's the Mexico City, it's these kind of major accidents we're talking about. Barrier management is to coordinate a set of activities for establishing and maintaining barriers so that they always fulfill their function. So this is it's a method that is normally applied for major accident scenarios where we have multiple barriers and a complex sequence of events. And I think this idea of multiple barriers, or kind of layers of cheese, acting together to stop a sequence of event from developing, is at the core of understanding what barrier management encompasses. And of course, the intention of barrier management is to control major accident hazards. And you do this by gaining strength of knowledge for the barriers and try to reduce uncertainty in the barrier performance. I have included a couple of pictures here as well. One is showing what's called the Swiss cheese model, where you see you have a hazard development and you have these slices of cheese with hole in them. The holes represent kind of weakenings in the barriers, degradations of the barriers that you want to avoid. So you want to minimize the number of holes. You want to make sure that you have as robust and, let's call it, watertight barriers as possible. I've also included a picture of bow tie, because as I'll get back to a bit as well, bow ties in terms of visualizing and assessing a major accident scenario and the associated barrier concept can be very valuable in this type of context. So I will not go into the details here. I just want to mention that you have kind of, in addition to the context related to which type of hazards this applies for, you also have a context or a framework related to regulations and standards. You have slightly various definitions across countries, and you have kind of, in Norway, we have Havtil, previously PSA, having a barrier memorandum, and you have guidance provided by research institutes on how to execute this for the oil and gas industry. In the UK, you have the HSE, you have the Safety Case Directive, and you have the COMA legislation. You also have, I'd like to mention, like a common international standard for oil and gas, that is the ISO 1776, that describes how you should do major accident hazard management. Also like to emphasize that although what is shown here is mostly specific to the petroleum industry, the principles and the methods are of course fully applicable to any industrial context, because the method is as such independent of the specific major accident hazards that you might have. I'll say a bit more now on the barrier management framework, because this is something I strongly believe cannot be underestimated. You need to have a good framework in the company, and you need to have good processes, you need to have the competence in order to do effective and efficient barrier management. And this needs to be integrated with existing systems and with other disciplines. Only then can you get high quality. If you don't have buy-in from management, if you're not able to integrate it with other activities in the company, you'll get poor integration, which is likely to yield the opposite. And in terms of actual documents, or call it framework entities that a company have, you normally have a company level barrier management philosophy or framework. This outlines how the company approaches barrier management in general, and how this should be done specifically on asset or unit or complex specific level. And then you have unit or complex specific barrier management document and processes that demonstrate control of the relevant major accident hazards for that specific unit. So that would, and also compliance with relevant requirements, that be company requirements or regulatory requirements. A bit more on the framework, because again, this is just like we're just scratching the surface. This is just a very, very high level. I want to mention that you have this life cycle development where you have during the project stage. This is when you identify the major accident hazards. You define the barrier concept and barrier strategy. all of course in conjunction with the risk analysis to make sure that kind of you have a barrier concept that is suitable to the risk analysis, so you have acceptable risk with this specific barrier concept. You also have to define the performance requirements for the barriers, because it's not enough to define them. You have to specify what kind of requirements they need to fulfill. And the requirements need to be verifiable. They need to be possible for someone beforehand of operation and during operation to actually verify that the status and condition of the barriers are good. And then lastly, in terms of kind of main headings you need to do, you need to define the barrier verification schemes. So you have defined the barriers, you have identified performance requirements, but you of course also need to define how will you verify the performance, because this is in the end what it concerns about, making sure that you have control of the barrier, that you verify the performance to substantiate good control over the major accident hazards at a specific asset. When you set up for operation, you have to verify the performance of barriers, and you also, extremely important, if there are some punches or gaps in the barrier performance, this needs to be recorded and conveyed to the operations team so that they are fully aware of any punches that is present from project phase taking into operation. You also have to prepare the maintenance and the monitoring programs. Katarina will talk more about the maintenance interface, and of course you want to kind of make it as easy for yourself as possible by preparing related activities in the company with the barrier management, so that you can monitor and verify as smoothly as possible. During operation, it's all about monitoring, control, and verifying the barrier performance, and also to correct and adjust and improve based on performance and conditions. This would be like any type of risk context. If you have changes in the barriers, in the conditions, major modifications, of course you need to have a good management of change process to make sure that you maintain the same level of risk, or at least acceptable level of risk, and update the barrier concept. I've showed some pictures as well. I will not explain in detail, but the picture is, the first is just kind of the life cycle stages from project to operation. There is a bow tie diagram here, this one. This is a very common tool for visualizing the barrier management or the major accident hazard scenarios, and to kind of investigate the barrier concept. You want to look at the barriers, how can they be weakened, how can they be degraded? So it's a way to assess or to analyze the barriers you have in place. There's also barrier hierarchy, could be relevant in some cases, subject to the context, and there's also kind of excerpts from performance standards, which typically encompasses a quite substantial list of performance requirements for the barriers, normally compiled in kind of, let's say, upper barrier system level, and often very, very much aligned with industry standards, if relevant for the specific context. Finally, I will share some lessons learned, and I think this is maybe, or hopefully, where we can provide most value today, because a lot of the theory is of course available online. Some lessons learned: you need to have buy-in from management and other discipline, as well as integrated with existing processes and systems. And if you execute barrier management poorly, if you don't do this, then you have a low effect on risk and a very high cost, because a lot about barrier management is quite time consuming. Identifying safety critical elements, or safety and environmental critical elements, and kind of making the interface with the CMMS, defining performance requirements. There are a lot of things here that are quite big and labor intensive. So if this is not done right, it typically creates tensions with other disciplines and a general reluctance against barrier management, which is of course what you want to avoid. The level of detail should be commensurate with the context. If you have, let's say, a simpler context and a simpler barrier concept, a major accident hazard setup, then you should kind of tailor the methodology to be suitable for that. Too much theory or too high granularity should be avoided if it's not required. Over time, active involvement related to implementation, documentation, follow-up of performance requirements should be had from other discipline areas, as well as subcontractors, suppliers. It's very highly recommended to optimize the workflow in the project. Because one thing a bit special about barrier management is that, at least in my view, it relates more to compiling information that has been generated by other disciplines, but compiling what is relevant of that information into the major accident hazard context. So ideally, you don't want to make too much new. You want to utilize what is already there, and you want to compile it together with disciplines and subcontractors to make this as effective as possible. Tools that you involve should be easy to use as far as possible. Existing tools and systems should be utilized. And lastly, very importantly as well, handover to operation should be planned as early as possible to make the transition of barrier responsibility and control as smooth as possible. That's it from me. Over to you, Katarina.
Thank you, Per-Ståle. So, how can we turn this barrier management theory into practice? I will share some thoughts and examples on how a barrier management system can be implemented. There are basically two main steps to ensure the intended functionality of safety barriers throughout the operational phase of an asset. Firstly, we need to identify all barriers and associated equipment, meaning that we need to find and identify each individual piece of equipment or procedure that is part of a barrier to prevent or mitigate a major accident from happening. And secondly, we need to find a way of incorporating this data, integrating this data into a CMMS, or maintenance management system, to ensure the intended functionality of barriers throughout the entire life cycle. And if we go a bit more into detail on the first step, what we want to do initially is basically to find all relevant safety barriers for an asset. This could be done, for instance, by looking at existing risk assessments, such as QRAs, HACCPs, LOPAs, etc. It's important to keep in mind that these barriers can be both technical or organizational or operational, or a combination. And we also both look at preventive barriers that prevent an event or incident from happening, as well as mitigative barriers that prevent a small incident from becoming a large and critical incident. A few examples of typical safety barriers could be, for instance, a shutdown system, again, to prevent a small incident from becoming a large accident. It could be an active fire protection system to contain or extinguish a fire. It could be passive fire protection to protect important structures or escape routes or sensitive equipment. Or it could also be human barriers or procedures detailing how an operator should act in a certain situation. And once we're confident that we have identified all our safety barriers, we need to break them down further into level detail to understand what individual pieces of equipment are needed for each barrier to function as a whole as intended. For instance, a shutdown valve could be part of a shutdown system, or a fire pump can be part of an active fire protection system, or a firewall or fire installation could be part of an passive fire protection system. And this part, basically identifying all safety critical equipment on a tag level, is often the most extensive part, the most time consuming part. It requires a lot of man hours, a lot of patience to go through all the relevant documentation, such as P&IDs, drawings, fire and gas layouts, fire and safety plans, cause and effects, equipment databases, to make sure that we have identified each single piece of equipment that is associated with a certain safety barrier. We can take the next slide. So once we're confident that we have identified all safety barriers and associated equipment, we have to find a way of incorporating this data and this information into our maintenance management system. So for a large asset, we could be talking about hundreds of different safety barriers and thousands or tens of thousands of individual pieces of equipment. So we need to find a way of handling all this information, of managing all this data, which is why we often develop some sort of barrier database containing all this information. In order to manage all the data and information in a good way, we also often want to categorize or group individual pieces of equipment to easier manage the barriers and also to assign different attributes and performance requirements and linking it to performance standards to be able to follow it up at a later stage. And this is where the link to CMMS comes in. So we need to incorporate all this data from our database into our maintenance management system so that we can plan and monitor and report all the necessary maintenance tasks to ensure that the performance requirements are met throughout the entire life cycle. So again, to identify and manage all safety barriers and associated equipment for an asset, it's an extensive piece of work. It takes a lot of time and it requires a lot of patience. But it is still important to get it done and to get it right. First and foremost, of course, because we want to make sure that we actually do prevent or mitigate any major accidents from happening. We want to ensure that we do avoid any major chemical spills, that we avoid any major fires, or that we avoid any explosions or other critical accidents that could result in the loss of human lives or result in serious harm to the environment or result in major financial loss. But the large benefit to our daily operation is also that by doing this task, by differentiating between safety critical equipment and non-safety critical equipment, we can also optimize the use of resources, meaning that we can allocate time and money and personnel efforts where it's most needed. And last but not least, this optimization of maintenance activities could also result in a reduced risk to personnel, since the maintenance task in itself can also pose a risk and be associated with danger. Not least for an offshore asset, for instance, where you might need to be transported by helicopters to and from the asset to be able to perform the maintenance task itself. We can take the next slide. Yeah. So before I hand over to Per Ståle and Terje again, I wanted to share some thoughts on success factors and lessons learned from this type of work. If this is done properly, it's again an extensive piece of work. And before initiating such a project, it's important to have a good structure to ensure a systematic approach. It's important to be consistent to ensure high quality results throughout the project, throughout the asset. And it's also, again, important to have transparency and traceability throughout the work to be able to understand the why and what role does a certain piece of equipment play in the larger picture, to be able to maintain this in a good way throughout the entire life cycle. These were some thoughts and examples on how barrier management can be implemented in practice. So I'll hand back to you, Per Ståle. Thank you.
Thank you. Yeah, thank you very much, Katarina. Very interesting indeed. And I think also what you're saying is kind of it just again and again, it emphasizes the importance of having a structure and framework, and it should be clearly defined as you start as well, because only then can you succeed when you get into the details of kind of actually executing it. Thank you very much. Next, we'll go over to you, Terje, and we'll hear more about the verification during operation of barriers.
Yeah, thank you, Per Ståle. So during my career, I have been working on both being a part of a verification team and also following up the results from these verifications. So here are some thoughts and lessons learned from me. Yeah, normally the technical barriers are followed up through the normal maintenance system. They're tested and inspected according to that system. But company would like to have independent verification done to verify the condition of barriers. So the main thing they want to, are they tested and follow up? according with the requirements, internal and external, and are they functioning accordance with the original design intent? And the last point, it's during a plant's lifetime, it's you will have changes in the operation, and also will be done modifications to the plant, and there are chances for, when doing these changes, that the barriers will not function as how they were intended to do, because they have the user changed, or the design of the plant have changes during the lifetime. You may also want to do verification to reveal the systematic failure and weakness of management of barriers. So you go like one step up to also verify the system itself. So is the system able to catch all the failures? Are they registered correctly? Are they reported correctly? It's a thing that's important for management to know. And benchmark and against best practices. Some companies, when they do this verification, they also verify against the newest best practices and standards. And they do this to see how are we doing now compared to the new standards. Can the barriers be improved? Are we on a acceptable safety level at this moment? And that's you want to do to really see how your plant is operating towards the best practice. Yeah. So during verifications, you will have some challenges. You need a skilled verification team, and they need to be available for a long period, 100%, typical 1 month. They will be 100% dedicated to this, to do a verification of a large plant facility is very time consuming. It also requires availability of the plant personnel, operation personnel, because they need to be available for interviews, helping the verification team, retrieving information, and accompanying site visits when the verification team visit the plant itself. One important challenge, especially for the older plants, is that documentation can be hard to find. And that may lead to unnecessary findings, because the documentation are there, but since the verification team cannot find it, they have to make a gap on it, and then there is a lot of work done just to close the gap after, which is considered not necessary. After recreations, the plant has to do closing of the gaps, and depending on the condition of the plant, you can have a large number of gaps, and that may overload an already busy operational organization. The plant may not be set up to handle so much modification work that closing gap may cause, so that will be can be a huge challenge for some plants. Handling of gaps against best practice, it's could be very demanding, because you want, after to close the gap, you want to do normally an alarm evaluation. Could you do changes here and improve safety, and how much should you do to improve safety? What are the limits that you can press the button, yes, we do this change. And it's my experience that is very time consuming, because it's a lot of evaluations, it's a lot of back and forth before coming to a conclusion. The last point, it's internal resistance in the operation organization. It's this operation organization, they may have a professional pride in operating this plant in a perfect manner, and an external team coming here and finding gaps and saying this is not good. It might cause some internal resistance that, yeah, this has never been a problem. So it's a challenge that shouldn't be underestimated for a company when doing these verifications. Yeah, and finally, some lessons learned. Of course, the verification team must be well prepared and familiarized with the facility. They need to look up on the drawings, look at the layout, and familiarize with the documentation before they start the verification. And the same is for the operation team. They should be well prepared and to assist retrieving information to avoid the unnecessary gaps, as I mentioned for the previous slide. And gaps findings should be clear and concise. There should be no room for doubt or interpretation. This has been a challenge in my experience for many verifications, that it's not clear what the gap are, and it's not clear how it should be closed, and that makes it's very time consuming, and you might do not the correct actions to close the gaps. And at last, if you are benchmarking against best practice, a strategy for handling these gaps should be prepared before the review to ensure the consistent handling of gaps. Because if it's not clear for the organization how this should be handled after a verification, there could be large differences of how these gaps are treated from department to department, from person to person. So it should be a procedure that's clear for everyone that's involved in this closing of the gaps. So yeah, so that's all from me.
Very good, Tyre. Thank you very much. Also very interesting, and after listening to you, I also understand there is this kind of great. There are a lot of complex problem statements within this area, but I think the one you touched upon is also very interesting, where you have this. It's okay if we're going to build something new, because then you can kind of set up everything perfect along the latest criteria and things like that. But of course, you have a vast range of, let's call it more mature assets as well, that were subject to different things when they were designed. But of course, you want them also to be as close to the best practice as possible. And within that domain, there is a lot of kind of interesting discussions and problem statement on how to think in this barrier management context. I think that that was the last part of the presentation. To summarize, I think some of the key takeaways, and I can say this will be shared. It will be available on our YouTube page after the webinar today. I think it's also probably possible to find at our homepage or company webpage. So I would recommend you to, if you run through it again, focus a bit on the lessons learned here, because again, I think this is where hopefully we can provide the most value. A lot of the theory is available online as well. And one of the core red lines has gone through the entire presentation is this about the framework and the systematic approach, because, as I said many times already, this is very to the detail, many places, thousands of tags, hundreds of performance requirements. If you don't structure it the right way, and if the end result don't give you the answer that really tells you something and helps you control the major accident hazards, you have not done it the right way. I think what we will do now is we'll go over to the questions and answers. We have received several good questions. Thank you very much for that. We'll try to answer as many as possible. And yes, on the first, on the recording, yes, I mentioned this will be shared later. I'll take the next question on the list on my side is there any checklist or reference for monitoring and review asset integrity during operational phase? So I would say in the barrier management context, this should relate to the performance requirements. And in terms of checklist or reference, I would say that you probably will have context-specific industry standards or company requirements. But I don't know, Tayo, do you want to share some thoughts on what you typically have available in terms of checklist or guidance reference for monitoring during operations phase?
Well, typically you will have the performance standard that especially when you're doing in these verifications, you will base your checklist or validation activities based on the performance standards, and also your like best practices standards for the company. So that's typically that's something that has to be prepared in advance of the doing verification.
Very good, thank you. And again, if we're not able to answer questions, or if you feel the answers didn't fully answer your question, please reach out after the meeting. So I'll take the next question on the list here, and it's for barrier management, are you using KPIs to monitor and review during project execution? I'm not sure if I fully understand the question, but I would say call it KPI, or it can have many names. I think during project execution, what is important is that you build this framework that we talked about, that is done in conjunction with the risk analysis, that you have identified the barrier strategies or the barrier concepts and define the performance requirements and the verification schemes. And then again, I also mentioned briefly this, you need to verify that the performance is good before you hand over to operation. And if there is any deviations during this verification, that needs to be kind of carried over to operation, and it should be highlighted in the barrier monitoring schemes and in the performance standards that you have deviations on some of your barriers. I think okay, I think we'll take one for you, Katarina, if you have some here. It's related to which are some of the softwares for CMMS that you can recommend. I don't know if you have any view on that.
I'm not sure I could answer that one specifically either. It depends so much on the type of structure you have, the type of company, and what your what the purpose, how you work. It's difficult to give a straight answer, unfortunately.
Yeah. Yes, I fully agree, and I think, kind of frankly speaking, I would think most of the commercially available CMMS tailored for the industrial context should be able to do this. In my experience, it's primarily not the CMMS system or the software that is the concern. The concern is in the framework or the structure, or how this is then constructed in the software itself, rather than the software as such being the challenge. Okay, I'll take one. I can take that. How do you operationalize organizational and operational barrier elements? Yes, this is a very interesting one. and I think it's one kind of with no simple answers. I would say I don't have I have seen various approaches for this at various companies. You could have dedicated performance standards related to these kind of barrier elements, and then you have performance requirements and how type of indicators saying something about how the status of them are during operation. There are also options where you tie in the operation organization elements more specifically to the overarching barrier systems and do it similarly. But this needs to be, everything about operation organizational need to be treated that's not as such related to the CMMS. This needs to be treated by the relevant systems for those elements, that being competence development, that being competence matrix or training and drills, how you make procedures, stage of procedure, those are other systems than you use typically than you do to verify and assure the technical barrier elements. Yeah, I think that also answers a bit the next, this on what should be in the CMMS. Okay, I'll take the next from Christopher. Thank you, Christopher. Considering the hierarchy for setting up barrier or SECE management, it seems obvious that the organizational maturity is vital to enable proper management and knowledge of SECE management. What should the focus be? It seems that it all depends on safety culture. Yes, I think if you have if you have a good safety culture as a foundation, that's an extremely good starting point. And I think that related to this about the maturity of the organization, what we should try to do is always to find the suitable level of detail in the framework. I think I mentioned in one of my slides that the level of detail should be commensurate with the context. So if you have, call it a less mature organization, you should not do the full-on most theoretic division of barrier functions. You should take a more pragmatic approach so that it is possible, based on the maturity of that organization, to actually get value from it. So I would say that is a very strong guideline for how to develop the specific barrier management framework for an individual company. Yeah, good. I'll just check the question. Just publish a bit more. Okay. Yes. Okay, let's take the next one from Naresh. Thank you. What are the documents must be reviewed before proceeding for verification for familiarization? I have to be honest, I don't fully understand the question.
I think I can answer that question. I think it's meant for this verification.
Perfect.
So yeah, so I will say typically you will have design basis documents, strategy documents, philosophy documents for the plant, performance standards, and layout drawings, and PFDs. I think that's, like, you can say it's the overarching documents that you should at least review before proceeding for the verification. That and those documents may have references to other documents you want to dive in before you perform the actual verification.
Thank you very much, Taya. I think we'll take one final question, and I think this is also, I think I'll send this to you, Taya, but it's related to how do you use verification results of barriers or SECE or SE to define the cumulative risk on board. So I guess the essence, how do you combine the verification with a risk level or the understanding of the risk for a specific asset?
Yeah, it's a bit different from company to company, but I think a normal or a one way to do it is to have special KPIs for this verification that's based on the criticality of the findings and to say the rate of closing the findings, and that will can be used for the management to see how was the safety level after just after verification and how much have we improved, and it will give also a good indication of the process of closing the findings, which may be very time consuming and take long time.
Yes, thank you very much, Taya. And I've seen some of these closing projects are very big. They're the kind of big projects in themselves. So I think I see that the time is 12:45. We'll end here. We understand that we probably or hopefully have an audience that is very busy. So I'd like to thank you all for attending this webinar. It will be available on YouTube a bit later. And if you have any more questions, please reach out to me, Taya or Katarina, and I wish you all a very nice day. Thank you.